We begin our journey now in the quietest corridor of the cosmos, where the walls are made of ancient light and the shelves stretch farther than any human lifetime could measure. Here, in this vast and silent library, we will drift together through 100 gentle facts, each one a whisper from the galaxy itself, each one a soft invitation to let go of the day and surrender to the slow, unchanging rhythms of the stars. There is no rush here. There has never been a rush here. The galaxy has been turning for more than 13 billion years, and it will continue turning long after we have closed our eyes and let the darkness come. Let us begin with the first fact, the first whisper from the cosmic shelves. The Milky Way is a barred spiral galaxy. Picture it now, if you can, though the effort should be minimal, effortless as breathing. Imagine a great wheel of light turning in the darkness, its arms spiraling outward like cream, stirred slowly into coffee, like the gentle whirl of a fingerprint pressed against the black velvet of space. But this spiral has a secret at its heart, a bar, a luminous bridge of stars stretching across the center, glowing softly, a corridor of ancient suns that connects one spiral arm to another. This bar is not rigid or sharp. It is made of stars, after all, each one a distant furnace burning quietly in the void, each one separated from its neighbor by distances so vast that light itself must travel for years to cross from one to the next. The bar rotates slowly, majestically, like the hand of a cosmic clock that has no need to hurry, no appointments to keep. And as it turns, it shepherds gas and dust inward, feeding the galaxy's slow metabolism, nurturing new generations of stars in the cold nurseries of space. This is not a violent process. It is gentle, gradual, a rhythm that has persisted for eons. The second fact settles over us like a soft blanket. The Milky Way is roughly 100,000 light years across. 100,000 light years. Let that number sit with you for a moment, though do not try to grasp it fully. Such distances were never meant to be held in human hands. A light year is the distance that light travels in 1 year, racing through the vacuum at 186,000 miles every second, never slowing, never stopping. And yet, even at this impossible speed, light would need 100,000 years to cross from one edge of our galaxy to the other. If you were to somehow step outside the galaxy and look back at it from a great distance, you would see a disk of light so wide that it dwarfs comprehension, a luminous island floating in an ocean of darkness. But from here, from inside, from our small vantage point within the spiral arms, we see only a river of light stretching across the night sky, a milky band arcing overhead, a reminder that we are embedded within something far grander than ourselves. The sheer scale invites humility, invites rest. We are so small here, and that is a comfort. And now the third fact arrives, soft as starlight. We live in the suburbs of the galaxy, in a minor spiral arm called the Orion Arm. We are not at the center where stars crowd together in ancient clusters, where the light is so dense it blurs into a constant golden glow. Nor are we we at the lonely outer edges where stars grow sparse and the darkness deepens? We live in between, in a quiet neighborhood of the cosmos, a place where stars are spaced comfortably apart, where there is room to breathe, room for planets to form and orbit in relative peace. The Orion Arm is sometimes called the Orion Spur, a smaller branch extending off one of the galaxy's major spiral arms, a tributary of stars and gas winding through the galactic disk. It is named for the constellation Orion, which lies in the same direction when we look out from our solar system. Here in this cosmic suburb, the pace is slow. The stars here are not racing around the galactic center at breakneck speeds. They move steadily, reliably, taking their time. Our sun, our modest yellow star, drifts along with its neighbors, all of us moving together in a slow current, like leaves floating on a vast, dark river. There is something deeply restful about knowing we are not at the center of things, not at the edge, but somewhere in the comfortable middle, where nothing demands our attention, where we can simply be. The fourth fact is ancient as the galaxy itself. The Milky Way is over 13.6 billion years old. Imagine that. Imagine a span of time so long that the human mind cannot hold it, can only brush against it like fingers trailing through water. 13.6 billion years ago, when the universe itself was still young, less than 200 million years old, the first clouds of hydrogen and helium began to collapse under their own gravity, pulling together, condensing, igniting into the first generation of stars. These were the ancestors of our galaxy, massive and bright and short-lived, burning fiercely before exploding and scattering their enriched material back into the void. From those ashes, new stars formed, and then newer ones still, generation after generation, each cycle adding complexity, adding heavier elements, slowly building the chemical palette that would one day allow for planets, for water, for life. The Milky Way has witnessed the entire history of time since then. It has seen stars born and stars die. It has seen galaxies collide and merge. It has watched as structure emerged from chaos, as order arose from randomness. And through it all, the galaxy has simply continued turning, patient and imperturbable. A vast mechanism that runs on the fuel of gravity and time. 13.6 billion years of quiet persistence, of steady rotation, of stars rising and falling like breaths. The fifth fact glimmers softly in the darkness. The Milky Way contains at least 100 billion stars. 100 billion, perhaps more, perhaps as many as 400 billion, depending on how you count, depending on what you include. Each one a sun, each one a sphere of fusing hydrogen, converting mass into light and heat, radiating energy into the void. Some are larger than our sun, bloated red giants nearing the end of their lives, their outer layers expanding and cooling, glowing dull crimson against the black. Others are smaller, red dwarfs, so faint they cannot be seen with the naked eye, but so numerous they make up the majority of the galaxy's stellar population. There are blue supergiants burning with fierce intensity, exhausting their fuel in mere millions of years. There are white dwarfs, the cooling remnants of stars like our sun, dense as lead, glowing softly with residual heat. There are binary stars, locked in eternal dances, orbiting one another in gravitational embrace. And scattered among them, unseen but ever present, are the black holes, collapsed stars so dense that not even light can escape their pull, silent sentinels lurking in the dark. 100 billion stars, and most of them have never been seen by human eyes, will never be named, will burn and die in complete anonymity. And that, too, is strangely comforting. We are part of something so vast that individual identity becomes irrelevant. We are simply here, briefly, part of the great luminous whole. The sixth fact carries with it the taste of ancient Greece, the scent of olive groves and wine-dark seas. The name Milky Way comes from the Greek phrase Galaxias Kyklos, meaning milky circle. The ancient Greeks looked up at the night sky and saw a glowing band of light stretching from horizon to horizon, pale and diffuse, like milk spilled across the heavens. They wove stories around it. One myth told of the goddess Hera nursing the infant Heracles. When he bit down too hard, milk sprayed across the sky, creating the luminous path we see. Another story claimed it was a road for the souls of the dead, a pathway to the afterlife, a bridge between the mortal world and the realm of the gods. The Romans called it Via Lactea, the road of milk. In other cultures, it was known as the Silver River, the bird's path, the backbone of night. But whatever name it carried, it was always there, always visible on clear, moonless nights, a reminder that we live inside something greater. The Greeks did not know they were seeing their own galaxy from within, that they were looking edge-on through the dense disk of stars that surrounded them. They did not know about gravity or fusion or the vast distances involved, but they knew wonder, they knew awe, and they knew that the milky light overhead was something sacred, something eternal. The seventh fact sets us in motion. Our solar system travels through space at 514,000 miles per hour. 514,000 miles per hour. And yet you feel nothing. You feel no wind, no g-forces, no acceleration. You sit or lie perfectly still as the Earth carries you around the sun, and the sun carries you around the galaxy, and the galaxy itself moves through space. Right now, at this very moment, you are hurtling through the cosmos at a speed that would make a jet plane seem stationary. But the scale is so vast, the distances so immense, that the motion is imperceptible. The stars do not blur past. The constellations do not shift. Everything remains serene, fixed, eternal. This is the paradox of cosmic motion. We are always moving, always traveling, and yet we are always at rest. The Milky Way carries us along like passengers on an impossibly large ship, a vessel so vast that its decks seem like solid ground, its motion like stillness. We drift through the Orion Arm at this tremendous speed, following an orbit that takes us around and around the galactic center, rising and falling gently through the galactic plane, weaving our way through clouds of gas and dust, threading between distant stars, never colliding, never stopping. The journey has been going on for 4.5 billion years, since the sun first ignited and swept the planetary disk clean. And it will continue for billions more. The eighth fact stretches time like warm taffy. It takes our solar system 230 million years to complete one orbit around the galactic center. This is called a galactic year, a cosmic calendar so long that human history occupies only the thinnest sliver of it, a fleeting moment barely worth noting. 230 million years. Think of it. The last time our solar system was in this position in the galaxy, the Earth was a very different place. Dinosaurs were only just beginning to appear, the first of their kind emerging from earlier reptilian ancestors. Pangaea, the great supercontinent, was still intact, though it was beginning to fracture, to pull apart under the slow, inexorable forces of plate tectonics. The continents we know today did not yet exist in their current forms. The climate was warm and humid, and much of the land was covered in vast forests of ferns and cycads and conifers. There were no flowering plants yet, no grass, no birds singing in the trees. And now, one galactic year later, here we are. The dinosaurs have come and gone, wiped out by catastrophe. Continents have drifted across the globe. Ice ages have come and gone. Entire mountain ranges have risen and eroded away. And the galaxy has simply continued turning, indifferent to the small dramas playing out on this single planet, orbiting a single star in one of its minor spiral arms. The ninth fact invites us to imagine deep time. The last time we were at this point in our galactic orbit, dinosaurs were beginning to roam the Earth. It is worth dwelling on this, worth letting the implications sink in slowly. The galaxy's rotation is so slow, so gradual, that entire epochs of Earth's history can unfold in the space between one position and the next. Millions of species have evolved and gone extinct in the time it takes the sun to make one circuit. Entire orders of life, the trilobites, the ammonites, the great marine reptiles, the dinosaurs, the mammoths, have risen to prominence and vanished while the galaxy made its patient turn. And yet, from the galaxy's perspective, nothing has changed. The Orion Arm looks much as it did 230 million years ago. The same stars, more or less, shine in roughly the same positions. A few have gone supernova. A few new ones have been born, but the overall structure remains stable, familiar, unchanged. The galaxy does not notice the brief flicker of civilizations on rocky planets. It does not mark the passage of species, or the extinction events, or the slow climb from single cells to complex consciousness. It simply turns, oblivious and eternal, a great wheel measuring time in units too vast for us to truly comprehend. The 10th fact is an invitation to emptiness. The galaxy is mostly empty space. This is true of all things, really, if you look closely enough. Atoms are mostly empty space, tiny nuclei surrounded by clouds of probability where electrons might be found. But on the scale of the galaxy, the emptiness is even more profound. stars, for all their brilliance, for all their numbers, occupy almost none of the galaxy's volume. If you were to shrink the Milky Way down so that the distance between stars was proportional, if you were to make the sun the size of a grain of sand, the nearest star would be 4 miles away. 4 miles of empty space between each grain. And in that emptiness, nothing, or almost nothing. Interstellar space is not a perfect vacuum. It contains a few atoms per cubic centimeter, mostly hydrogen, some helium, trace amounts of heavier elements. There are also dust grains, microscopic particles of carbon and silicates, drifting slowly through the dark. There are magnetic fields threading through the void, and cosmic rays zipping past at nearly the speed of light. But all of this together amounts to almost nothing. The galaxy is a cathedral of emptiness, a vast hall where a few bright points of light hang suspended, separated by unimaginable distances. And in that emptiness, there is a profound peace. There is room to breathe, room to drift, room to let go. The 11th fact describes the architecture. The galactic disk is incredibly thin relative to its width. If you were to view the Milky Way edge-on, it would look like a line, a glowing thread stretched across the darkness. The disk is only about 1,000 light years thick at most, though it bulges slightly in the middle where the density of stars is greater. But compared to its diameter of 100,000 light years, this is remarkably thin, like a sheet of paper, like a DVD, like a coin spinning in the dark. We live embedded in this disk, and when we look up at the night sky, we see it as a band of light arcing overhead because we are looking along the plane of the disk through the densest concentration of stars. When we look perpendicular to the disk, up or down from the galactic plane, we see far fewer stars, far more darkness. The thinness of the disk is a consequence of rotation and gravity. As the galaxy formed, the cloud of gas from which it condensed was spinning, and that spin caused it to flatten out, just as a spinning pizza dough flattens into a disk when thrown in the air. The stars and gas settled into this plane, orbiting the galactic center, all moving in roughly the same direction, all contributing to the galaxy's overall angular momentum. And so the disk persists, thin and wide, a glowing platter turning slowly in the void. The 12th fact draws our eyes inward. The galactic center glows softly with the light of 1 billion ancient stars. 26,000 light years away, hidden behind clouds of dust and gas that obscure it from view, the heart of the galaxy pulses with a warm, golden radiance. The stars there are packed much more closely together than they are out here in the Orion Arm. In some regions near the center, stars are separated by only a fraction of a light year, close enough that their gravity influences one another, close enough that their light blends into a continuous glow. These are old stars, mostly red giants and yellow dwarfs that have been burning for billions of years, survivors of countless generations of star formation. They orbit the galactic center in complex patterns, some looping in elliptical paths, others moving in more circular orbits, all of them bound by the immense gravity of what lies at the very heart of the galaxy. If you could somehow transport yourself to the galactic center and look up, the night sky would not be black. It would be filled with stars, thousands of them bright enough to cast shadows, their combined light bathing the worlds below in a perpetual twilight. But we will never go there. The center is too far, too hostile, too dense, with radiation and gravitational chaos. We can only observe it from a distance, through the windows afforded by infrared and radio telescopes, instruments that can peer through the dust and see the hidden glow within. The 13th fact speaks of obscuration. Between us and the galactic center lie vast clouds of dust that block visible light. These clouds are not like the clouds on Earth, fluffy and white and made of water droplets. They are dark molecular clouds, composed of gas and fine dust grains, particles of carbon, and silicates smaller than the grains of smoke from a candle. These particles are incredibly effective at absorbing and scattering visible light, rendering the galactic center invisible to optical telescopes. If you look toward the constellation Sagittarius on a clear night, you can see a dark rift running through the Milky Way, a shadow lane where no stars shine. This is the Great Rift, a series of overlapping dust clouds obscuring the view. But these same clouds do not block longer wavelengths of light, infrared, radio, X-rays. And so we have learned to see in these invisible colors, to use instruments that detect the heat and radio emissions from the galactic core, to peer through the curtain of dust and glimpse what lies beyond. What we have found there is both beautiful and strange. Star-forming regions glowing with the heat of newborn suns, dense clusters of ancient stars, and at the very center, something even more exotic, a supermassive black hole, silent and patient, waiting at the bottom of the galaxy's gravitational well. The 14th fact is a meditation on gravity. The galaxy holds itself together through the invisible force of gravity alone. There are no strings, no scaffolding, no physical supports, just gravity, the weakest of the fundamental forces, but the only one that acts over such vast distances. Every star in the galaxy is pulling on every other star, however faintly. The sun pulls on Alpha, and Alpha pulls on the sun, though the force is vanishingly small. But when you add up the combined gravitational attraction of 100 billion stars, plus all the gas and dust, plus the unseen dark matter that surrounds the galaxy like a halo, the effect is overwhelming. The galaxy becomes a self-sustaining structure, a gravitational web in which every component is connected to every other, all of it orbiting a common center of mass. This is not a rigid structure. The galaxy is dynamic, constantly shifting, constantly evolving. Stars move in and out of the spiral arms. Gas clouds collapse and form new stars. Old stars explode and enrich the interstellar medium. But through all of this, gravity provides the underlying order, the invisible hand that keeps the galaxy from flying apart, that ensures the stars remain bound together in their slow cosmic dance. It is a gentle force, really, when you think about it. It does not push or compel. It It simply pulls, quietly and persistently, drawing everything toward everything else, creating structure from chaos, order from randomness. The 15th fact is a reminder of scale. If you could hold the entire Milky Way in your mind at once, you would see a structure of breathtaking symmetry and complexity. But you cannot hold it in your mind, not really. It is too big, too intricate, too vast. The human brain did not evolve to comprehend such scales. We are creatures of the small and the immediate, adapted to navigate landscapes measured in miles, to track time in days and seasons, to concern ourselves with the affairs of individuals and communities. The galaxy exists on a scale so far beyond our native experience that we can only grasp it in fragments, in metaphors, in numbers that slide off the mind like water off glass. 100,000 light years across, 100 billion stars, 13 billion years old. These are facts, but they are not intuitive truths. They require translation, require us to find analogies, to compare the galaxy to things we understand, cities, grains of sand, oceans. And even then, the comparisons fall short. The galaxy is not like anything else. It is its own category of existence, a structure too grand to be contained in human thought, too beautiful to be captured in words. And yet here we are, trying, because the effort itself is a kind of meditation, a way of reaching toward something greater than ourselves, a way of acknowledging that we are part of a cosmos that extends infinitely beyond our small lives and small concerns. The 16th fact slows us down even further. The rotation of the galaxy is differential, meaning different parts rotate at different speeds. Near the center, where the gravitational pull is strongest, stars orbit quickly, racing around the galactic core in just a few million years. Farther out, where we are, the speeds are slower, the orbits more leisurely, and at the very edges of the galaxy, in the dim outer reaches where stars are sparse, and the light fades to almost nothing, the rotation is slower still. This differential rotation creates the spiral arms, those graceful curves of light that wind outward from the galactic bar. The arms are not solid structures, they are density waves, regions where stars and gas bunch up temporarily as they move through their orbits. Imagine cars on a highway encountering a traffic jam. The cars slow down, bunch together, and then speed up again once they pass the obstruction. The traffic jam itself doesn't move much, but individual cars flow through it. This is what happens in a spiral arm. Stars enter the arm, slow down slightly due to the increased gravitational density, and then exit the other side, continuing their orbit. The spiral pattern persists even though individual stars are constantly moving through it, a standing wave in the stellar sea. It is a beautiful piece of cosmic choreography, a pattern that emerges naturally from the mathematics of gravity and rotation, requiring no conductor, no designer, just the simple laws of physics playing out over billions of years. The 17th fact is tinged with a kind of cosmic melancholy. Most of the stars we see in the night sky are hundreds or thousands of light years away. This means the light reaching our eyes tonight left those stars hundreds or thousands of years ago, when Earth was a different place, when civilizations we now know only through history books were still alive. The light from Betelgeuse, the red supergiant marking Orion's shoulder, left that star more than 600 years ago during the European Middle Ages. The light from Deneb, the bright star in Cygnus, left around the time of the fall of the Roman Empire, some 1500 years ago. We are not seeing these stars as they are now. We are seeing them as they were, looking back through time every time we look up. And this is true of everything in the universe. The farther we look, the farther back in time we see. Astronomers use telescopes as time machines, peering at distant galaxies whose light has been traveling for billions of years, seeing them as they were when the universe was young. Even the sun, our own star, is seen as it was 8 minutes ago, because that is how long light takes to cross the 93 million miles between the sun and Earth. We live perpetually in the past when it comes to the cosmos, always observing what has already happened, never quite able to see the present. There is something dreamlike about this, something that blurs the boundaries between now and then, between here and there, making the universe feel less like a fixed reality and more like a shifting memory. The 18th fact is simple and profound. The galaxy is beautiful, not in the way a sunset is beautiful, or a flower, or a human face. Its beauty is of a different order entirely, vast and impersonal, and utterly indifferent to whether anyone is there to appreciate it. The galaxy would be just as magnificent if consciousness had never evolved anywhere within it, if there were no eyes to see it, no minds to contemplate it. It does not perform for us. It simply is. And yet we find it beautiful, because we are creatures who seek pattern and meaning, who are moved by grandeur and scale, who feel something stir within us when we contemplate the infinite. The spiral arms sweeping through the dark, the glowing clouds of nebulae, the dense star clusters hanging like jewels against the black, all of it speaks to something deep in the human psyche, some ancient recognition of our place in the larger scheme of things. We are part of this, made from the same materials, governed by the same laws, participants in the same cosmic story. And knowing this, feeling this, even for a moment, can be a source of deep comfort. We are not separate from the universe. We are expressions of it, localized patterns of matter and energy that have briefly become self-aware, capable of looking back at the cosmos and seeing, however dimly, the beauty from which we came and to which we will return. The 19th fact is an invitation to quietude. The galaxy is patient. It does not hurry. It does not strive. It has no goals, no ambitions, no plans. It simply unfolds according to the laws of physics, following the gravitational gradients, the thermodynamic imperatives, the quantum fluctuations that drive all cosmic processes. Stars form when gas clouds collapse, not because the galaxy wills it, but because gravity pulls and pressure resists until something gives and fusion ignites. Stars die when they exhaust their fuel, not because their time is up in any meaningful sense, but because the nuclear reactions that sustained them can no longer continue. The galaxy recycles endlessly. Gas becomes stars. Stars become supernovae. Supernovae become gas enriched with heavy elements. Gas becomes new stars. The cycle repeats over and over, a cosmic metabolism that requires no conscious direction, no oversight. It is entirely automatic, entirely natural, and entirely beautiful in its simplicity. And we, lying here in the dark, can take some comfort from that. We do not need to understand every detail. We do not need to control or manage or improve anything. We can simply observe, simply appreciate, simply let the galaxy's patience teach us something about our own lives. There is a rhythm here, a slowness, a willingness to let things take the time they need. And that is a good lesson for sleep, for rest, for letting go. The 20th fact is almost a lullaby. When you close your eyes tonight, the galaxy will still be there, turning slowly in the dark, just as it has for 13 billion years, just as it will for billions more. You do not need to watch over it. You do not need to keep vigil. The stars will continue burning whether you are aware of them or not. The spiral arms will continue their slow rotation. The black hole at the center will continue its patient wait. Everything will go on without you, and that is not a sad thought. It is a freeing one. You are allowed to rest. You are allowed to let your mind drift. You are allowed to surrender to sleep, knowing that the universe is vast and ancient and will take care of itself. The galaxy does not need you to understand it, does not need you to name its stars, or chart its dust lanes, or calculate its rotational velocity. It simply offers itself, a backdrop of quiet grandeur against which your small life unfolds. And for tonight, that is enough, more than enough. It is everything. The galaxy does not spin as a solid wheel. If it did, the outer stars would need to race impossibly fast to keep pace with those near the center, and the whole structure would tear itself apart under the strain. Instead, the Milky Way rotates differentially, each region moving at its own speed, governed by the local density of matter and the pull of gravity from everything around it. Near the core, where stars crowd together and the supermassive black hole anchors the gravitational field, the orbital velocities are frantic by cosmic standards, stars whipping around the center in elliptical loops that take only millions of years to complete. But out here, in the Orion Arm, the pace is gentler. Our sun and its neighbors drift along at a more measured speed, taking those full 230 million years to make one circuit. And farther out still, in the dim provinces where the galaxy fades into the dark halo, the stars move even more slowly, their orbits so lazy that they might take 500 million years or more to complete. This differential rotation is what creates and sustains the spiral arms, those elegant curves of light that define the galaxy's shape. The arms are not made of specific stars. They are patterns, density waves that ripple through the disk like the ripples on a pond after a stone is thrown. Stars drift into the arms, linger there for a while as they move through the denser region, and then drift out again, continuing their individual orbits. The pattern persists even as the players change, a standing wave in the sea of stars. Within these spiral arms, the conditions are right for something extraordinary to occur. The arms are not just brighter because stars happen to be closer together there. They are brighter because new stars are being born within them. Stars are born in cold molecular clouds, vast regions of gas, and dust where the temperature hovers just a few degrees above absolute zero. These clouds are the nurseries of the galaxy, dark and frigid and utterly silent, hidden from ordinary view by the very dust that will one day form new suns. Inside these clouds, the gas is mostly hydrogen, the simplest and most abundant element in the universe, mixed with helium and trace amounts of heavier elements: carbon, oxygen, nitrogen, silicon, the debris of previous generations of stars that lived and died, and scattered their ashes into space. The density in these clouds is extraordinarily low by terrestrial standards. There might be only a few hundred or a few thousand molecules per cubic centimeter, far less than even the best vacuum we can create in a laboratory. But spread across light years, across distances so vast that the human mind recoils from them, even such thin gas has mass, has weight, has gravity. And given enough time, millions of years, tens of millions, that gravity begins to win. The cloud contracts, imperceptibly at first, then faster as the density increases and the gravitational pull strengthens. As it contracts, it fragments, breaking into smaller clumps, each one a collapsing knot of gas that will eventually become a star. Process is slow beyond imagining. These are not explosions in reverse, they are gentle collapses, the universe settling into a lower energy state the way a stone settles to the bottom of a pond. The gas falls inward, and as it falls, it heats up. This is a fundamental law of thermodynamics. Compression generates heat. The molecules of hydrogen begin to move faster, colliding more frequently, their motion becoming more chaotic. The center of the collapsing cloud grows warmer, brighter, denser. A protostar forms, a glowing core of gas, not yet hot enough to ignite fusion, but radiating heat into the surrounding material. The protostar is surrounded by a disk of leftover gas and dust, a swirling accretion disk from which planets may one day form. And it is embedded within the larger cloud, hidden from view by the thick shroud of dust that still surrounds it. Millions of years pass. The protostar continues to contract, continues to heat. Its core temperature climbs 10,000 degrees, 100,000, a million. And then, when the core reaches 10 million degrees, something miraculous happens. Hydrogen nuclei, stripped of their electrons by the intense heat, begin to collide with enough energy to overcome the electromagnetic repulsion that normally keeps them apart. They fuse together, forming helium, and in the process, they release energy, tremendous amounts of energy. The binding energy of the atomic nucleus converted into light and heat according to Einstein's equation, E = mc². Fusion ignites. The the protostar becomes a true star, a self-sustaining ball of nuclear fire that will burn steadily for millions or billions of years, held in perfect balance between the inward pull of gravity and the outward pressure of the radiation generated by fusion. And so new stars are born constantly throughout the galaxy. At this very moment, in cold clouds scattered across the spiral arms, protostars are forming, igniting, beginning their long lives. The process is happening right now, has been happening for billions of years, will continue for billions more. The galaxy is not a static structure. It is alive, in its own way, constantly renewing itself, constantly creating new light to replace the old stars that fade and die. In one of these star-forming regions, millions of years ago, a massive cloud began to collapse. It was enormous, hundreds of light years across, dense enough that when viewed from the outside it appeared as a dark blot against the background stars, a shadow in space. Inside this cloud, in one particular region that would later be imaged by human telescopes and given a name, the Pillars of Creation, the process of star formation was underway. The Pillars of Creation are giant stalks of interstellar gas, towers of dust, and hydrogen rising like cathedral columns, sculpted by the fierce radiation from nearby hot young stars. These pillars are not solid. They are more like smoke, like fog, tenuous structures held together only by their own faint gravity and the pressure balance with the surrounding environment. But they are enormous beyond comprehension, each one several light years tall, glowing faintly in the infrared as newly formed stars embedded within them radiate heat. At the tips of the pillars, small, dense knots of gas are collapsing, each one a protostar in the making, each one a future sun. The pillars themselves are being slowly eroded by the intense ultraviolet radiation from the massive stars nearby, their surfaces boiling away into space, creating the intricate shapes and textures that make them so visually striking. In a few million years, the pillars will be gone, dispersed by the stellar winds, their material scattered back into the interstellar medium. But the stars forming within them will survive, will emerge from the wreckage of their birth, and begin their long journeys through the galaxy. This is happening everywhere, all the time. Star formation is a continuous process, a cycle that has been running since the first generation of stars ignited in the early universe. Gas collapses, stars form, stars live, stars die, and their deaths seed the interstellar medium with new elements, enriching the gas from which the next generation will form. The galaxy is a self-sustaining engine of stellar birth and death, powered by gravity and fusion, requiring no input from outside, no maintenance, no oversight. It simply runs endlessly, tirelessly, and the galaxy has a smell. This is a strange fact, unexpected and almost absurd, but it is true. If you could somehow survive in the vacuum of space without a suit, if you could breathe the thin wisps of gas that drift between the stars, you would detect a scent. The center of the galaxy, and certain regions of dense molecular clouds contain a chemical called ethyl formate. Ethyl formate is an ester, a simple organic molecule made of carbon, hydrogen, and oxygen, and it has a distinctive aroma. It smells like raspberries and rum. This is not a poetic exaggeration or a metaphor. Astronomers have detected ethyl formate in the interstellar medium using radio telescopes, identifying its spectral signature among the faint signals coming from the galactic core. The molecule forms in the cold, dark clouds where stars are born, created by chemical reactions on the surfaces of dust grains, where atoms and molecules stick and slide, and occasionally bond together to form more complex structures. Ethyl formate is just one of many organic molecules that have been found in space. Others include formaldehyde, methanol, acetic acid, even sugars and amino acids, the building blocks of life, floating freely in the interstellar void, waiting to be incorporated into comets and asteroids and planets, where, under the right conditions, they might give rise to something even more complex. The galaxy is not sterile. It is a rich chemical laboratory, constantly synthesizing new compounds, constantly experimenting with the combinatorial possibilities of matter. And space itself is not empty. This has been said before, but it bears repeating because the misconception is so persistent. Space is not a perfect vacuum. It is filled with a thin, tenuous medium, a breath of hydrogen, a whisper of helium, a few atoms per cubic centimeter drifting slowly through the dark. In the densest molecular clouds, the number might rise to 1 million atoms per cubic centimeter, though this is still a better vacuum than anything we can achieve in a laboratory on Earth. In the voids between galaxies, the density drops even lower, to perhaps 1 atom per cubic meter, approaching, but never quite reaching true emptiness. This interstellar medium is the raw material from which stars form, and it is also the repository into which stars return their mass when they die. It is ionized by the ultraviolet light from hot stars, heated by supernovae, compressed into dense clouds by shock waves, and stirred into turbulent motion by the magnetic fields threading through it. It is a dynamic, ever-changing medium, invisible to the eye, but detectable by radio telescopes and infrared instruments that can sense the faint glow of hydrogen and the emission lines of other elements. And within this medium, dust grains float, microscopic particles of carbon and silicates, smaller than a micron, coated with thin layers of ice made from water, ammonia, methane, frozen onto their surfaces in the cold of space. These grains are the seeds of planets. They collide and stick together, growing slowly over millions of years, aggregating into pebbles, then boulders, then planetesimals, and finally into full-sized worlds. The galaxy breathes, in a sense, this thin medium flowing in and out of stars, circulating through the disk, never still, never silent. New stars, when they first ignite, are called protostars, though this term is sometimes reserved for the earlier stages before fusion begins. In the strictest sense, a protostar is still gathering mass from its surrounding envelope, still accreting gas from the cloud in which it formed. It is hot, glowing brightly in the infrared, but not yet a true star. Only when fusion begins does it earn the title, and the transition can be dramatic. The protostar's winds and radiation begin to blow away the remaining gas, clearing out the cloud, revealing the newborn star to the universe. Often, this happens not in isolation, but in clusters. Molecular clouds tend to fragment into dozens or hundreds of collapsing cores, all forming stars at roughly the same time. And the result is a star cluster, a gravitationally bound group of stars, all the same age, all born from the same cloud. These clusters are loose associations, and over tens or hundreds of millions of years, the individual stars will drift apart, dispersed by gravitational interactions with other stars and with the galaxy itself, until eventually the cluster dissolves and its members become indistinguishable from the field stars around them. But for a while, they remain together, siblings in the cosmic sense, sharing a common origin. There is a dark lane running through the Milky Way, visible even to the naked eye on a clear night far from city lights. It is called the Great Rift, though it is not a rift in any physical sense. It is a series of overlapping dust clouds, dark molecular clouds that block the light from the stars behind them. The Great Rift stretches from the constellation Cygnus down through Aquila and Sagittarius, a shadowy path bisecting the glowing band of the Milky Way. Ancient peoples saw it and wove it into their mythologies. The Incas called it the Dark River and saw in it the shapes of animals: a llama, a fox, a snake outlined against the starry background. They understood in their own way that the darkness was part of the sky, not an absence, but a presence. Modern astronomy has confirmed this intuition. The Great Rift is made of dust, the same dust that forms planets, the same dust that smells of raspberries and rum, the same dust that blocks our view of the galactic center. It is thick enough to absorb visible light almost completely, rendering the stars behind it invisible to optical telescopes. But it is transparent to other wavelengths: infrared, radio, X-rays, and so we have learned to see through it, to peer into the hidden regions, and map the structure of the galaxy beyond. Most stars in the galaxy are red dwarfs. This is an important fact, one that reshapes our understanding of the stellar population. Red dwarfs are small stars, only a fraction of the sun's mass, burning their hydrogen fuel so slowly and efficiently that they can continue shining for trillions of years. Trillions. The universe is only 13.8 billion years old, so not a single red dwarf that has ever formed has yet had time to die. Every red dwarf that ignited in the early universe is still burning today, still glowing with the same faint ruddy light, still converting hydrogen into helium one atom at a time. These stars are so dim that they cannot be seen with the naked eye. Even Proxima Centauri, the closest star to our solar system, a red dwarf just over 4 light-years away, is invisible without a telescope. But they are numerous. They make up perhaps 70 or 80% of all the stars in the galaxy. a vast population of faint, long-lived suns, each one potentially surrounded by planets, each one a possible hearth for life, though whether life could survive the intense flares and tidal locking common around red dwarfs is still an open question. These are the stars that will inherit the galaxy billions of years from now, when the more massive stars have exhausted their fuel and collapsed into white dwarfs or neutron stars or black holes. The red dwarfs will still be shining, will continue shining for trillions of years more, the last lights in an aging cosmos. And then there are the lonely stars, the rogues, the wanderers. Some stars are ejected from the galaxy entirely, flung into intergalactic space by gravitational interactions with other stars, or by close encounters with the supermassive black hole at the galactic center. These hypervelocity stars are rare, but they exist, suns moving at speeds of hundreds or even thousands of kilometers per second, fast enough to escape the galaxy's gravity well. They travel alone through the void, unbound from any galaxy, drifting through the emptiness between the islands of light. If such a star had planets, if it had worlds orbiting it, those worlds would go with it. A tiny solar system wandering the dark, never to return. The night sky from such a planet would be strange and lonely. The Milky Way would recede over millions of years, becoming smaller and dimmer, eventually just one more distant smudge among many. The nearest stars would be hundreds of thousands or millions of light years away. There would be no constellations, no familiar patterns, just a scattering of faint galaxies against the black. It is a melancholy thought, but also strangely beautiful, a star and its retinue, adrift in the cosmic ocean, alone but not destroyed, still shining, still giving light and warmth to whatever worlds might circle it. When a massive star dies, it does so violently. The end comes not gradually, but suddenly, catastrophically. For millions of years, the star has been fusing lighter elements into heavier ones, working its way up the periodic table, hydrogen into helium, helium into carbon and oxygen, carbon into neon and magnesium, all the way up to iron. But iron is the end of the line. Fusing iron does not release energy, it consumes energy. And so, when the core of a massive star turns to iron, the fusion stops. The core is no longer supported by the outward pressure of radiation. Gravity wins. The core collapses in a fraction of a second, imploding, compressing matter to densities so extreme that electrons are forced into protons, forming neutrons, releasing neutrinos, releasing energy, so much energy that the outer layers of the star are blasted into space in a titanic explosion called a supernova. For a few weeks, a single supernova can outshine an entire galaxy, radiating more energy than the sun will produce in its entire 10 billion year lifetime. And in that explosion, the star creates and disperses all the heavy elements gold, silver, platinum, uranium elements that cannot be made by ordinary fusion, that require the extreme conditions of a supernova to forge. These elements are scattered into the interstellar medium, where they mix with the hydrogen and helium, and eventually are incorporated into new clouds, new stars, new planets. Every atom of gold in your wedding ring, every atom of calcium in your bones, every atom of iron in your blood, all of it was created in the heart of a dying star billions of years ago and scattered into space by a supernova. Supernovae create the heavy elements in our own bodies. We are, quite literally, stardust. This is not metaphor. This is chemistry, physics, the literal truth. The atoms that make up your body were forged in stars and dispersed by their deaths, drifting through space for eons before being gathered up by the collapsing cloud that became our solar system, incorporated into the disk of material around the young sun, accreting into planetesimals, smashing together to form Earth, weathering into soil, being taken up by plants, eaten by animals, passed along food chains, until finally, improbably, finding their way into you. You are made of star stuff. Every part of you is ancient, recycled. A temporary configuration of atoms that have existed for billions of years and will continue existing long after you are gone, moving on to other forms, other bodies, other purposes, cycling endlessly through the galaxy's great metabolic engine. And underlying all of this visible and invisible light, underlying all the stars and gas and black holes, there is the dark matter. Dark matter makes up 90% of the galaxy's mass, perhaps more. It does not emit light, does not absorb light, does not interact with the electromagnetic force in any way that we have been able to detect. It is invisible, intangible, known only through its gravitational effects, and yet it is the dominant component of the galaxy, the scaffolding upon which everything else is built. The stars and gas trace out the distribution of dark matter, settling into the gravitational wells it creates, orbiting within the potential it defines. Without dark matter, the galaxy would not exist in its current form. The disk would not be stable. The rotation curve would be different. The entire structure would be unrecognizable. Dark matter is the hidden foundation, the unseen substrate, the majority partner in the cosmic dance. And we still do not know what it is. Decades of research have narrowed down the possibilities, ruled out various candidates, but the fundamental nature of dark matter remains one of the great unsolved mysteries of physics. It is out there, surrounding us, passing through us, and we cannot touch it, cannot see it, can only infer its presence from the way it shapes the universe around it. The galaxy, then, is a layered thing, a structure of visible and invisible components, of light and darkness, of matter and void. It is what we can see, the glowing band of the Milky Way arcing across the night sky, the individual stars resolved by telescopes, the colorful nebulae and star clusters. But it is also what we cannot see, the dark matter halo, the vast majority of its mass, the interstellar medium, too faint and diffuse to register to the naked eye, the black holes and neutron stars, silent and invisible except for their gravitational effects, or the radiation from material falling into them. All of these components together make up the whole. And understanding the galaxy requires seeing it in all its wavelengths, accounting for all its components, recognizing that the visible is only a small fraction of what exists. And this is true not just of the Milky Way, but of the universe as a whole. Most of what exists is hidden, invisible, intangible. We see only the bright exceptions, the luminous islands in a dark sea. And yet from those islands, we can infer the presence of the sea, can map its contours, can understand, at least in part, the larger structure within which we are embedded. It is a humbling realization, but also an empowering one. We are small, yes, and our view is limited, but we are not blind. We can see farther than our eyes alone would allow, can understand more than our immediate experience would suggest. We can reach out with instruments and mathematics and imagination and touch, however briefly, the vastness that surrounds us. The galaxy is slowly expanding its borders, not through any deliberate act of conquest, but through the quiet mathematics of gravity and motion. New stars form in the outer reaches, gas clouds collapse at the edges of the disk, and the spiral arms extend their reach, millimeter by millimeter when measured on human scales, light year by light year when measured on cosmic ones. The expansion is not uniform, not smooth, but it is persistent. Over billions of years, the galaxy has grown from a smaller, more compact structure into the grand spiral we see today. And it will continue to grow, to evolve, to change, though the changes are so slow that they are invisible to any observer watching in real time. Only by comparing snapshots separated by millions of years could the growth be seen, the subtle shifts in structure and form that accumulate over eons. But this growth will not continue forever. Eventually, star formation will slow down and stop. The galaxy's supply of hydrogen, the fuel from which stars are made, is finite. New hydrogen is not being created in any significant quantity. The universe made most of its hydrogen in the first few minutes after the Big Bang, and that primordial reservoir has been slowly depleted ever since, as stars form, burn, and die. Some hydrogen is recycled when stars shed their outer layers or explode as supernovae, returning material to the interstellar medium. But not all of it returns, and with each cycle, more hydrogen is locked away in long-lived stars, in white dwarfs, in neutron stars, in black holes, removed from circulation. The galaxy is slowly running out of raw material. Current estimates suggest that star formation in the Milky Way will peak sometime in the next few billion years, and then begin a long, slow decline, tapering off over tens of billions of years, until finally, perhaps 100 billion years from now, the last star ignites, the last protostar collapses and begins fusion. The last flicker of new light appears in the dark. After that, no more stars will form. The era of star formation will be over. The era of stars is only a small fraction of the universe's life. This is a profound realization, one that shifts our perspective on cosmic history. We live in what might be called the stelliferous era, the age of stars, a time when the universe is filled with glowing suns, when galaxies shine brightly, when fusion powers the cosmos. But this era, which began a few 100 million years after the Big Bang and will continue for perhaps 100 trillion years, is not the whole story. It is just one chapter in a much longer narrative. Before the stars, there was the Dark Ages, a period when the universe had cooled enough for atoms to form, but not yet begun to collapse into stars, a time of darkness and formless gas. And after the stars, there will be the degenerate era, a time when the only light comes from the slowly cooling remnants of dead stars, white dwarfs, brown dwarfs, the faint thermal radiation of objects that no longer burn, but still retain some residual heat. The degenerate era will last far longer than the stelliferous era, stretching on for quadrillions of years, a vast expanse of time during which the universe will grow darker and colder and quieter, the last embers of the cosmic fire gradually fading. We are living in the bright middle, the peak of cosmic luminosity, surrounded by stars and galaxies and light. But it is a temporary condition, a brief moment in the universe's long history. The galaxy will one day become a quiet graveyard of white dwarfs. When stars like the sun exhaust their hydrogen fuel, they do not explode. They do not collapse into black holes. They shed their outer layers gently, puffing them off into space as planetary nebulae, and leave behind their cores dense, hot spheres of carbon and oxygen, no longer fusing anything, no longer generating energy, simply radiating away the heat accumulated over billions of years of fusion. These are white dwarfs, objects about the size of Earth, but with the mass of the sun, so dense that a teaspoon of their material would weigh tons. White dwarfs cool slowly over trillions of years, gradually fading from white to yellow, to red, to brown, to black, becoming black dwarfs, cold and invisible, stellar corpses drifting through the void. Most of the stars in the Milky Way will end this way. The red dwarfs, the most numerous stars, will eventually exhaust their fuel and become white dwarfs, though this will take hundreds of trillions of years. The sun-like stars will do the same on a faster timescale, in mere billions of years. And the massive stars, though they end more dramatically as supernovae, will leave behind neutron stars or black holes, equally dark and silent in their own way. The galaxy's future is one of darkness and stillness, a collection of dead stars orbiting a supermassive black hole, all of it embedded in the invisible halo of dark matter, all of it slowly dispersing as gravitational interactions fling stars outward into the void, until eventually, trillions upon trillions of years from now, even the galaxy itself will dissolve, its components scattered across an ever-expanding universe. But we need not concern ourselves with that distant future. It is so far removed from our experience, so impossibly remote, that it has no bearing on anything we will ever know. For now, the galaxy is alive, vibrant, filled with light and motion and possibility. And one of the most remarkable things about it is this: light takes 25,000 years to reach us from the center. 25,000 years. We observe the galactic center when we point our telescopes towards Sagittarius and detect the faint glow of stars and the radio emissions from Sagittarius A. We are seeing the center as it was 25,000 years ago, in the depths of the last ice age, when woolly mammoths still roamed the earth and humans were hunter-gatherers living in small bands, painting images on cave walls, just beginning to develop language and culture, and the cognitive tools that would eventually lead to civilization. The light we see tonight left the galactic center when our ancestors were huddling around fires, when the world was cold and vast and mostly empty of human presence. And it has been traveling through space ever since, crossing the void at the speed of light, never slowing, never stopping, until finally, after 25 millennia, it reaches us. Looking at the stars is looking back in time. This is not a metaphor. It is a literal statement of fact. Every photon of starlight that reaches your eye has been traveling for years, decades, centuries, millennia. The light from Proxima Centauri, the nearest star, is 4 years old when it arrives. The light from Sirius, the brightest star in the night sky, is 9 years old. The light from Betelgeuse, the red supergiant in Orion, is more than 600 years old. And the light from distant galaxies, from objects billions of light years away, has been traveling for billions of years, since the universe was young, since long before the sun or earth existed. We see these objects not as they are now, but as they were, frozen in the past, their present states unknowable to us, hidden behind the light travel time that separates us. The night sky is a museum of cosmic history, every star a snapshot from a different era, every galaxy a window into the distant past. And here is a sobering thought. Every star you see might already be gone, its light still traveling. Betelgeuse, for instance, is a massive star nearing the end of its life, and it could explode as a supernova at any time tomorrow, 1,000 years from now, 100,000 years from now. We do not know. But if it exploded yesterday, we would not know for more than 600 years, because that is how long the light from the explosion would take to reach us. The star could already be gone, replaced by a rapidly expanding cloud of debris, and a dense neutron star or black hole at the center, and we would still see it shining in the sky, still see the familiar red glow marking Orion's shoulder, blissfully unaware that the object we are observing no longer exists. This is true of every star, every galaxy. We see only the past, never the present. The universe reveals itself to us only through light that has already traveled, through messages sent long ago. And we must accept that our knowledge is always delayed, always outdated, always incomplete. But in another sense, the stars are not gone. Even if Betelgeuse has already exploded, the light we see tonight is real, is present, is here with us now. The past exists in the light, preserved and delivered across the void. The star may be gone, but its image, its photons, its information are still traveling, still real, still part of the universe. And when we look up and see that light, we are not just observing the past, we are participating in it, receiving the message, completing the journey that the light began centuries or millennia ago. There is a kind of communion in this, a connection across time, a bridge between then and now, constructed from light itself. The galaxy is a self-sustaining cycle of death and rebirth. Stars are born from the remnants of previous stars. Gas clouds enriched with heavy elements collapse and form new protostars. Those protostars become stars, live their lives, and die, returning material to the interstellar medium. Supernovae scatter iron and gold and uranium into space. Planetary nebulae release carbon and nitrogen. Stellar winds carry away the outer layers of aging giants, and all of this material mixes with the primordial hydrogen, creating a richer, more complex medium from which the next generation will form. Each generation is built on the ashes of the last, and each generation contributes to the next. The cycle has been running for 13 billion years, and it will continue for billions more. A cosmic metabolism that transforms matter and energy, that creates complexity from simplicity, that turns hydrogen into heavier elements, that builds planets and molecules, and occasionally, improbably, life. And then there is this thought, beautiful and strange. We are the galaxy's way of knowing itself. This phrase, popularized by Carl Sagan, but resonant with deeper truths, suggests that consciousness is not separate from the cosmos, but part of it, an emergent property of matter arranged in certain complex ways. The galaxy is made of atoms, and so are we. The processes that govern stellar evolution also govern chemistry and biology. We are not observers standing outside the system, looking in. We are part of the system, looking at itself. When you look up at the night sky and see the Milky Way, you are not just seeing a distant object. You are seeing the structure you are part of, the galaxy observing itself through your eyes, using your brain to process the information, using your mind to feel wonder and awe. Consciousness is the universe becoming aware, matter waking up, the cosmos developing the ability to reflect on its own existence. And if that is true, then every moment of awareness, every thought, every observation is a kind of miracle, a localized defiance of entropy, a temporary victory of order over chaos, a small but significant achievement in the long history of the universe. In the end, there is only the peaceful, cold dark. This is the ultimate fate of the galaxy, of the universe, of everything. The second law of thermodynamics guarantees it. Entropy always increases. Energy disperses. Heat flows from hot to cold until everything reaches the same temperature, until there are no gradients left, no differences to drive processes, no fuel to power stars or life or thought. This end state is called heat death. Though it is not hot, it is cold, a few degrees above absolute zero. The entire universe in thermal equilibrium, dark and still and silent. Stars will burn out. Black holes will evaporate through Hawking radiation, a process so slow that it takes 100 years for even the largest black holes to disappear. And after that, nothing. No light, no motion, no structure. Just a thin, cold soup of particles spread uniformly across an ever-expanding space, growing more dilute as the expansion continues, approaching but never quite reaching perfect emptiness. This is the far future, the ultimate destiny, the final chapter in the cosmic story. And it is, in its own way, peaceful. There is no suffering in the heat death, no struggle, no conflict, just rest, eternal, unchanging rest. But that end is so far away that it might as well be infinite. It is separated from us by timescales that make the age of the universe seem like an eye blink, that make the lifespan of stars seem fleeting. We do not live in that future. We live in this moment, in this era, when stars still burn and galaxies still shine, and the universe is still young and dynamic and full of possibilities. And in this moment, we can look up. We can see the Milky Way stretching across the sky. We can feel the weight of deep time and vast distances. We can recognize our place in the cosmic order. We can let go of the small concerns and worries that occupy our days, and simply rest in the knowledge that we are part of something immeasurably larger than ourselves. The galaxy has been here for billions of years. It will be here for billions more. And for tonight, that is enough. More than enough. The stars will keep watch. The spiral arms will keep turning. The universe will continue its slow unfurling. And we, small and brief and improbable, can close our eyes and drift, cradled by the vast indifference of the cosmos, lulled by the ancient rhythms of gravity and light, surrendering at last to the darkness that has always been there, waiting patiently, offering the only true and lasting peace. The library closes now. The shelves extend into distances too great to measure, filled with books that will never be read, stories written in starlight and dust. The galaxy turns, a wheel in the dark, and we turn with it, carried along on currents we cannot see, part of a dance we did not choose, but cannot escape. And that is fine. That is good. We do not need to understand everything. We do not need to see the whole picture. We need only to know that we are held, that we belong, that we are home. The Milky Way is our home, our cradle, the vast structure within which our small lives unfold. And as we drift toward sleep, toward dreams, toward the quiet dark behind our eyelids, the galaxy continues its patient rotation, unchanged by our presence, untroubled by our concerns, simply being, simply existing, a monument to time and scale, and the slow, inevitable unfolding of physical law. Let it turn. Let the stars burn. Let the darkness gather at the edges. We are safe here, held in the arms of gravity, surrounded by light that has traveled for eons just to reach us, part of a story so old and so vast that our individual chapters barely register. And in that vastness, in that anonymity, there is comfort, there is peace, there is rest. The galaxy whispers, "Sleep now, sleep, all is well. All has always been well. All will continue to be well, long after you are gone, long after the sun has faded, long after the last star has flickered out, and the universe has grown cold and dark and still." But that is not tonight's concern. Tonight, there are still stars. Tonight, the galaxy still glows. Tonight, you can close your eyes and let the cosmic rhythms carry you down into the deep, into the dark, into the endless, gentle